Next, we will see the synchronization of threads and how threads are going to be communicate with each other, and what is suspending, resuming, and stopping threads, and we'll have multi-threading and all in this particular topic. Next, we will see the synchronization. So, what is a thread and how we are going to be create a thread, and how we can create more than one thread, multiple threads, and is alive method and join thread. And next is the thread priorities. We come across all these things, and next we will see the synchronization of threads. Next is the synchronization. When two or more threads need to access a shared resource, they need some way to ensure that the resource will be used by only one thread at a time. The process by which this is achieved is called synchronization. So imagine that the two threads are eagerly competing for a single shared resource. So at the time we need to give a chance to only one thread at a time, and the remaining thread has to wait until the first thread has to finish its usage. So no two threads or three more than two threads can use the shared resource at a time. So we need to synchronize those threads by using a synchronization mechanism. Here, the key concept for the synchronization is the monitor. Here, we need to allow only one thread to enter into the monitor and make use of the shared resource. Once the time is over or the task is over, simply that particular thread will come out of the monitor, and another thread which is waiting for the monitor will enter into the monitor, also known as the semaphores. A monitor is an object that is used as mutually exclusive lock or mutex. Only one thread can own a monitor at a given time. So no two threads can have the resource or shared resource at a time. Only one thread can own that particular resource at a time. When the thread acquires a lock or enter into the monitor, the remaining has to wait. It's said to be enter the monitor like that. And all other threads attempting to enter the locked monitor will be suspended until the first thread exits the monitor. These other threads are said to be waiting for the monitor. So all the remaining threads has to wait to get a chance, and only one thread can enter into the monitor and it can use the resource, shared resources. The next one is the synchronization can be done in two ways, either by adding a synchronized keyword to the methods, or the second one is you can have a synchronized statement or a synchronized block. So whenever any resource or any method which is shared among more than two threads, that method make that method as a synchronized method. That is the first category. And the second thing is we can have a block of information as a synchronized, which is having the object, and the particular block is make that one as a synchronized block. We will see the first one using the synchronized method. And here any method to enter an object's monitor, just call a method that has been modified with the synchronized keyword. While a thread is inside a synchronized method, all other thread has to wait. And to exit the monitor and relinquishes control of the object to the next waiting thread, it is as same as the scenario. So whenever any monitor any thread enter into the monitor, here entering into the monitor we can name that one as the method which is synchronized method. So whenever any method which is synchronized is acquired by any thread, the remaining thread has to wait until it relinquishes the control. It notifies the remaining threads to make use of that particular method. So until that, though the method will have certain block or certain wait methods or certain sleep method, the method may continue go on executing that particular things. It waits and it executes the remaining statements. Why? Because it is simply having all the resource of that particular method. You will see a simple example here. First of all, we see a non-synchronized application. Then we will just add a synchronized statement to the existing methods. So here we are having a method with having a class with the name of call me, and inside call me you are having only one method with the name of call. And here this is a call method is a what you can say shared resource, and all threads are eagerly waiting to execute this call method. So here the call method receives one parameter with the name of string, and it shows the value on the screen by using system.out.println. And here we are having one try block. There you are having one sleep method. Every time this particular thread is suspended for 1 second or 1000 milliseconds, and any exceptions raised, we need to catch the exceptions and show the message like interrupted. If everything is fine, simply it waits 1000 milliseconds, and it prints the statement system.out.println closing the curly square bracket. So here you are supposed to show the information within the square brackets. Whatever the information sent by that particular thread, we need to show inside square brackets. And next we are having one more class with the name of caller. Caller is implements runnable. So here you are creating any thread which is implementing through runnable interface. So here I took one string MSG and one call me reference of previous class, and one thread reference T. And we are having one constructor caller, and caller will have two parameters. First one is an object of call me class, and one string yes. And the TARG is going to be assigned to target, that is the call me reference, and S is going to be assigned to MSG, and T is allocating memory for T by using new thread of this particular current thread, and invoke the start method by using t.start. Now the thread is come to run stage by invoking run method internally. The run method will simply call the target.call method, which is a shareable method. So by passing MSG information. So here we are just maintaining two classes. One class is having one method which is shareable among two or three methods, two or three threads, and the second class is creating a runnable interface, and we are having one constructor and one run method. The run method is invoked by that particular thread object t.start method. And see the main method how it is. So inside main method, which is defined in some other class, and inside main method we create one target, one object, and three methods here, three objects for caller object, caller class. See here the caller second class, you are creating three objects, OB1, OB2, OB3, and first object is created its memory by using new operator and pass the two parameters. One is object of call me method, call me class, and second is hello, a simple string. The second object, the same target, that is object of call me, and synchronized one more word. The third object, the same target is the one first parameter, and word is the second parameter as string. The three objects are invoking this particular what you can say constructor caller, and passing the first object to TARG and the second string to yes. And here you are invoking and assign the values object to object and string s to MSG, and invoking the thread by just using t equal to new thread, and invoke the method start method t.start. Now internally it invokes the run method, and you are invoking that particular call method by passing MSG. So here you are passing hello, synchronizer and word to the newly created threads. And inside try block you just added one more word, object 1 dot t dot join, and object 2 dot t dot join, object 3 dot t dot join. So join method is a method which is used to wait for the main thread to join the child threads. Why? Because the child thread has to complete their execution and exit from the execution and hand over all the things to the main thread. It simply relinquishes control to main thread. After completion of all the child threads, then only the main thread has to suspend. So finally you will get all the thread. After completion of all the threads, simply the main thread will suspend, and you'll get the output like this. So compile the code and run the application, will get. So here the output should be in zigzag manner. So first the thread will simply show the information hello, but not closing the braces. Why? Because it is suspended certain period of time, 1 second or 1000 milliseconds. So instead of waiting, the next thread will come into the monitor, come into the execution stage and simply execute certain statement. Here immediately the world is going to be executed, and next synchronizer is going to be executed. So and after the first closing bracket appears, the second closing bracket and third closing bracket. So this information is not properly displayed over here. Why? Because on suspending a particular thread, the remaining thread will come into the CPU and execute its own block. The same three threads are going to be execute the same method, call method. So you will get first information, but closing system.out.println closing bracket will be executed later. Why? Because every thread is suspended for 1000 milliseconds. So you apply the same program for synchronized way. Alright, so you just add a word, keyword, synchronize it to the method. See here, so the three threads are waiting for eagerly to acquire a resource in order to execute its own block. Just add a synchronize, which is represented in red color, to the method and execute the same program. So here it appears like this. The only one keyword added to the method, call method, with the keyword synchronized, and everything is the same application, and you add, the output should be like this. So on executing or on acquiring shared method, the first thread hello is going to be executed and wait for 1 second, and the last statement is closing the bracket will be appear on the screen. So once this task is over, it simply quit from the execution. The second thread will come into the picture. It may be the world or it may be the synchronizer, whatever it is. The second thread enter into the block, monitor and execute its own task, and it waits for 1 second and simply close the square bracket, and simply it exits from the execution. The third method acquire the shared method and enter into the monitor and execute all the statements which are there inside call method. It shows the information and finally it close the square bracket and simply it come out of the application. So here you are getting all the information in a proper manner, that though you are mentioned asleep inside a synchronized method, but the thread has to wait and execute the remaining part of the code. It never give a chance to the other thread to go for executing its own task. This about this things happen inside with the support of this synchronization. So next one is, we can get the same by means of one more application is there here. The same program here, I define one printable method as a synchronized method, before not synchronized, and next is the synchronized. Here the thread is suspended for 400 milliseconds, and I define two threads here, my thread 1 and my thread 2, and I execute this application. So here I created two threads, and t1 dot start and t2 dot start. So the first thread is going to be executed with the multiples of 5 into 1, 5 into 2, and so on. The second thread is going to be executed with 100 into 1, 100 into 2, like that. So every time we are having a simple loop here, 1 to it iterates for 1 to 5 times. So first thread will have the multiples of 5, and second thread will have the multiples of 100. So on executing this particular program without any synchronized statement, it shows the random values like 500, 10, 200, 15. So first thread, second thread, first thread, second thread, and so on. It goes in different manner. But whenever you add a keyword synchronizer to this particular application, the same program will run in a systematic order, that the first thread has to finish all its resource and all its iterates. It shows the values 5, 10, 15, 20, 25, and so on. And next thread, the second, after completion of the all iterations, it simply come out of the monitor. The second thread will enter into the monitor and executes its own task by multiples of hundreds. This is a simple application. You just copy and paste and run the application and see how it appears. So next one is the synchronized statement or synchronized block. So here just it is not adding a simple keyword before a method. Of course it is a simple manner, but it is not fulfilled for all the cases. So imagine that if you want to synchronize access to objects of a class that was not designed for a multi-threaded access. So say for example you want to synchronize any object which is not designed for multi-threaded and that was not created by us, but a third party has created and they are supposed to access the resource, the shared resource. In that situation, how can access to an object of this class can be synchronized? The question here, so the third party which created any thread, of course it is not a multi-threaded and it is going to access any shared resource. How can you can control that particular things? So for this we are having a synchronized block here. So we need to put all the information inside a block, synchronized block, and we can have a synchronization between or among the threads. So we'll see how it appears. The synchronized block is like this. So synchronized is a keyword and open parenthesis and inside mention an object and close the parenthesis. Inside the block we need to mention the statements of that particular synchronized code. Here object is a reference to the object being synchronized. Next is the last statement. A synchronized block ensures that a call to a method that is member of objects occurs only after the current thread has successfully entered objects monitor. So whatever the objects thread enter into the monitor, that objects will have the resource and it enter into the monitors and have acquire the information. See how it appears with a simple application. The same program here also, the caller is a one class, whatever we represented in previously, and you added the one more block here in the caller implements runnable. Inside public void run, instead of calling target.call directly, that particular statement is enclosed within a block, synchronized block. So synchronized followed by the target. Here the target is an object of call me. Now this object is going to be a handover to the synchronized block, and inside you are invoking the call method with the target. So object name dot the method name call and pass the message value MSG. So here you just added a block with an object which is going to be synchronized. That object is invoked internally the appropriate shared method, and you will get the same information what we had earlier with appropriate braces. It opens the first statement and ends the last statement with a square bracket and so on with a systematic order. The same application is there here. I didn't add any more. I just run the same application with added this block. Next one is we'll having one more. This is all about thread applications, and the next we will have one more, that is inter-thread communication. So why we go for synchronizing threads and why we go for putting that particular threads inside with the keyword synchronization, synchronized, or try to put inside a synchronized block in order to make use of shared resource properly. No two threads will acquire the same resources. Why? Because if you are adding any information and meantime some other is using that particular information, simply it leads to race conditions. So we should not allow any particular thread, once he is using any shared resource, the remaining thread has to wait until it finishes its work. Once it simply come out of the monitor, and a next thread which is eagerly waiting for the resource, they can enter into the monitor, they can use that shared resource. So in order to synchronize all these, we can have a proper communication takes place between the threads. Next one is the inter-thread communication. How threads are going to be communicate with each other? Is it necessary to communicate with each other? The only thing is, the inter-thread communication or cooperation is all about allowing synchronized threads to communicate with each other. So whenever two threads are synchronized, one thread will enter into the monitor, the remaining thread has to wait. How it knows to wait? How can it is not trying to acquire the monitor? So the system or this inter-thread communication will give you certain mechanism that once any thread enter into the monitor, it simply asks the remaining threads to wait. Once it finishes its task, it simply come out. While coming out of that monitor, it notifies the remaining threads or any thread to make use of the monitor. Think that we are having more than one thread, so it notify all the methods, notify all the threads to make use of the shared resource or monitor. So based on the priorities, based on the importance of the particular thread, the thread will acquire the monitor and make use. Once any thread enter into the monitor, simply it calls the wait method to wait for the resource until it finishes. So these are three things happen here. How the threads are going to be communicate with each other. Here we are having the three methods. So first is the wait method. In order, the wait tells the calling thread to give up the monitor and go to sleep until some other thread enters or with the same notify. And the notify, it simply wakes up the thread that call the wait and the same object. Notify all in the sense the thread that call up wait on the same object. One of the threads will be will be granted access the monitor. So whenever any thread enter into the monitor, it simply invokes the wait, the calling thread, and to wait for the remaining threads, to ask the remaining threads to wait. And once it simply finishes, it notifies the thread or it notify all the threads by using notify all to make use of the resource. Anyone can get an access. See how the methods are there. These methods are declared as declared inside within an object. Object is a class. The final wait without parameters and with single parameter long timeout, and it throws interrupted exception. And notify all without any parameters. And the best example for this is a producer and consumer problem. So as long as producer is producing the things and consumer can consume the values. If producer is unable to produce, consumer has to wait. And if consumer is goes on consuming and without producer, so it leads to race condition. So based on producer and consumer, we need to wait and notify all. So we're having a nice example for this. And before going to this example, we are having one more representation with a simple diagram. How the threads are communicate with each other and how methods are invoked. So just go through a simple example here. And we are having three states here: entry set, the owner, and wait set. And the first here, the first enter into the thread enters to acquire a lock, acquire a monitor. So first stage is whenever a thread which is eagerly waiting to acquire any shared resource, they can enter into the entry state, or thread can enter into to acquire a lock. The second one is this the here in the first block the three threads are eagerly waiting for to enter into the monitor. So these three are running one after one parallelly. And the second one is lock is acquiring by only one thread. So here the thread is going to be acquiring the monitor, lock in the sense monitor. The thread enter into the monitor and they can make use of the shared resource. So this is the only one thread can enter into the lock or monitor. And the third one is now thread goes to waiting state. The third one is which is going to be wait state. If you call wait method on the object, otherwise it releases the lock and exits. So think that the running thread which is enter into the waiting stage by invoking the method wait. The fourth one is if you call notify or notify all method, thread moves to the notified state. So think that here waiting threads on releasing this particular lock, it notifying the remaining threads, so they can enter into the waiting stage. That is the fourth one. The fifth one, now thread is available to acquire lock. So whatever the waiting threads, they can acquire the lock again. Enter into the monitor. Anyone among these two, anyone can enter into the monitor and execute its own task. The next one, the last stage is after completion of the task, threads releases the lock and exits the monitor state. So whenever the thread which is running make use of this monitor and executing its own task, once it is finished, it simply exits from the monitor state. That is about the sixth point or the sixth stage. So please go through this diagram and parallelly, and how thread can acquire a lock or a monitor, and how it can execute, and how it enter into the wait stage, and notifying how it enter into the ready stage and enter into the monitor again. It is a continuous process. As long as the more threads are eagerly waiting, it goes for forever continuously, and by communicating with wait, notify and notify all methods, and once the task is over, simply it exit from the monitor. And the next one is we will see a differences between wait and sleep. The wait method releases the lock, and sleep method doesn't release the lock. Sleep is a simple method which waits suspend certain period of time, but wait is not like it, simply release the lock. And wait is a method of object class, and sleep is a method of thread class. And wait is non-static and sleep is a static method, and wait should be notified by notify or notify all methods, but sleep after specified amount of time, sleep is completed. So say for example, if you mention sleep of 1000 milliseconds, after 1000 milliseconds simply come out to the execution state. There is a simple difference between wait and sleep. And we're having a simple example for this inter-thread communication. And here we are having a class with the name of customer, and I added one variable with the name of amount equal to 10,000. And here I am two methods with the name of withdraw and deposit. And these two are synchronized methods, and withdraw in the sense it accepts one parameter amount and it shows some information going to withdraw. If the amount, this amount in the sense the amount which is a variable amount, class variable, this dot amount, if this dot amount is less than the amount, whatever the amount you entered, I mean existing amount, if it is lesser than the amount actually withdraw amount, the system shows less balance, wait for deposit. And having a wait here, and simply the particular thread will suspend and it wait, and the thread is the monitor is going to be handed over to the next thread. And if not the case, simply it deduct the money from the actual amount, and it shows the value information on the screen like withdraw completed. And deposit is one more method. Here it accepts some one parameter integer amount, and it shows the values going to deposit, and here it simply adds the amount to the local class variable amount, this dot amount plus equal to amount, and shows the values deposit completed. So once it is over, it notifies the thread. In the sense, now it is releasing from the monitor and it is notifying to the remaining thread, which is waiting for the monitor to execute. And the next one is the main method here. So inside main method, public static void main. So define one object for customer C, and create one thread, new thread. So here you are invoking run method, and inside run method c dot withdraw and add 15,000 to that, and by putting curly braces and dot start. So the newly created thread on creating the thread, it calls the run method immediately within this, and the one more thread for deposit. So here you are withdrawing 15,000. So initially the value is only 10,000. So it waits, and the next thread is going to be deposit one more 10,000. Now the value becomes 20, and later this 15,000 is going to be withdrawn. So this is a simple application here. So initially it shows less balance waiting for deposit, and next one is going to deposit is done, and deposit is completed, next withdraw is completed. So here based on the value, it has to wait the value whether the value is sufficient or not. So like that. So one thread is waiting for another thread in order to add a value. So like that, these two threads can communicate with each other. So next one is deadlocks. We will see deadlocks later. So this is all about inter-thread communication, and we are having one example in lab programs where we can have producer and consumer problem. We will discuss later, and we will stop this application here.